Earth is only inhabitable because of its atmosphere, a thin layer of gas which accommodates thriving life forms with tolerable temperatures and precipitation. The five layers are composed of 78% nitrogen, 21% oxygen, and trace amounts of other gases. Weather occurs in the troposphere. The stratosphere contains ozone, which filters much of the sun's harmful UV rays, and meteors disintegrate in the mesosphere. Then follows the thermosphere and exosphere. Weather is the curious interaction between the atmosphere and the sun. Areas of uneven heating and cooling perpetuate characteristic weather patterns of the many regions around us. The forms of precipitation of water are the result of the circulation of water among the land and sky. The sun's heat evaporates water into the sky where it condenses into clouds and eventually falls back to Earth. Runoff from groundwater and from streams collect and the cycle begins again, constantly supplying and dispersing water to the world's ecosystems. As many other systems and processes on the Earth, climates are perpetuated by the sun. The atmosphere provides Earth with a natural warming effect. Special molecules called greenhouse gases absorb some heat radiated from the sun, while the rest is radiated back into space. This warming is necessary because without the atmosphere retaining energy, the Earth would be a cold, lifeless planet such as Mars. And yet, for all Earth's majestic and miraculous beauty, we as humans find ourselves colliding with nature. In our newly industrialized world of spreading technologies and mass production, it is becoming ever more apparent that this rampant growth is squandering the natural resources of the environment. Scientists agree that the environmental cost of supplying ourselves with energy and urbanizing the natural landscape is becoming a problem. Plants provide a biological service of photosynthesis, which removes CO2 from the air it consumes. Because most of the vegetation on Earth is north of the equator, the summer months see an increase in plants, and therefore a decrease in carbon dioxide. The fluctuation resulting from this constant normal change in CO2 is seen here as a respiration and inhalation of the atmosphere. But the overall rise in carbon dioxide over recent years poses a serious global threat. Scientists have linked the burning of fossil fuels to a rise in carbon dioxide emissions and other greenhouse gases, which in turn correlates with the dangerous rise in global temperature. This is global warming. The top major contributors of greenhouse gas emissions include exhaust from automobiles and smoke from coal-burning power plants. An increase of forest fires or deforestation for land clearing has lessened the amount of trees which can remedy excess CO2. Any resource-consuming method releasing quantities of carbon dioxide, methane, nitrous oxide, or even water vapor contributes to the effect. These mass emissions of gases cause the atmosphere to trap more heat than it does naturally. And in turn, the Earth becomes hotter. Increases of just a few degrees of the average global temperature can reform climates. The IPCC has released graphs showing human industrial influence on the atmosphere. The past century in world history has seen a sharp increase in air pollutants, specifically greenhouse gases. Based on the current rate of economic growth, these levels are projected to get worse. The most compelling and ominous evidence is the correlation between CO2 concentration and the Earth's temperature. The increase of greenhouse gas pollutants yields an increase in global temperature. The melting of polar ice caps and glaciers across the globe is a crucial concern of scientists. The ice here is ultra-sensitive. The albedo property of ice allows it to reflect sunlight, while properties of water cause it to absorb more heat. The warmer water causes the ice near it to melt, and more water is dumped into the ocean and is heated, speeding the process. This is known as positive feedback. If the Greenland ice shelf melts, It will dump enough cold fresh water into the ocean to critically disrupt or reroute the vital flow of ocean and air currents and change climates across the globe. In some regions, it is becoming so much warmer that the soil, which is supposed to be permanently frozen, is thawing, causing trees to lose their anchor and tilt. They have been nicknamed drunken trees. An overall warmer ocean can cause storms such as hurricanes to intensify. Erratic moisture patterns will lead to droughts in many areas. This may lead to crop failures and famine. As already has happened in 2005, weather conditions will cause the number of tornadoes to increase. Another devastating effect of the melting ice caps would be a rise in sea levels, displacing millions in low-lying cities across the globe.
For every foot the sea rises vertically on the typical East Coast beach, about 100 feet are taken away by erosion and submergence permanently. The loss of one of the major ice sheets, which could raise sea level by many, many feet, maybe 20 feet or more, and that could drown much of coastal civilization as we know it.
Though difficult to evaluate, probably the most devastating ecological repercussion would be the biological damage inflicted on species and habitats. Drowned polar bears have been found, a clear sign that the melting ice is a serious threat to others along with humans. Scientists have estimated that because of habitat loss, the population of emperor penguins has decreased by 70% since 1950. Delicate ecosystems thriving with life cannot tolerate higher temperatures. Global warming is to blame for the killing of precious coral reef ecosystems. The dead, skeleton gray coral appears as a bleached coral reef. And because of a hotter range of temperatures, seasonal species exclusive to warmer climates could thrive in more areas, spreading the diseases they carry to more parts of the world. These catastrophic events may not be far from the future, but fortunately for the human race, there are measures that can be taken to slow our environmental impact. The best way is finding cheaper and cleaner energy alternatives to eliminate emissions of greenhouse pollutants at its source. Windmill farms and photovoltaic cells provide cheap, clean, and renewable energy. Use public transportation whenever possible. Fuel-celled hybrid buses eliminate the need to release CO2 from its engines. Reduce, reuse, and recycle. By recycling half of your household waste, you can save up to 2,400 pounds of carbon dioxide annually. If every family in the U.S. replaced one incandescent bulb with a compact fluorescent bulb, it would eliminate 90 billion pounds of greenhouse gases, equivalent to taking 7.5 million cars off the roads. Using efficient cooling and heating systems can save 2,000 pounds of carbon dioxide per person per year. The possibilities of energy conservation are endless. Science isn't needed to prove that working with nature is the best method for preserving it, because everything is connected. Our actions have prompted a crisis that could escalate far beyond a chance for recovery. The environmental issues of the 21st century call for the human race to rise to the occasion, to secure our future and the well-being of the one planet we call home.